So I'm gonna go ahead. I've started recording.
Okay. All right, guys. Good morning. Good morning. Thanks again for meeting with me this morning. My name is Guelord Mpagazihe, and I'm a civil engineer, my profession, and I focus more in transportation engineer. Who I work with infrastructure engineering, located in Chicago, Illinois, and I attended University of Minnesota. Actually, a little fun fact about me is um, if I'm not doing engineering, I love roller skating and I love drawing as well. And um, I've traveled to more than 30 countries now. And also, the scariest thing I've ever done in my life is bungee jumping, and I have some cool photos here to show y'all. Has anybody ever jump before?
Oh, wow, I never went bungee jumping, but I have been
What
zip
about
lining. I don't
what
think
about
it was.
skydiving or something that crazy?
I think the
Oh,
closest I've done is zip lining, but I never went like this high up.
yeah, the
Yes, I
highest
would.
I've been was rock climbing. I haven't been too high up.
Well, I would not recommend it because the entire time I was questioning my decisions, and it's one of the scariest things I've ever done. Um, but I'm happy I did it. Would I ever do it again? Yes, I would do it again, but only because I was so scared the first time that I don't even remember doing it. So I would love to do it again just so I can be more conscious and accepting of the activity. So, but I wanted to make this position a little bit more interesting and more engaging. So I kind of prepared some questions along the slides to kind of ask you guys, and was actually hoping I was hoping maybe if if you guys could give your answers in the chat. I don't know if I can see the chat.
Yeah, we can do that.
Can type
Okay.
up our answers.
Let me see. I'm just trying to see if I can see the chat.
Right
All
next
right,
to the share button. Yeah, right next to the share button. There
there
should
it
be a
is.
chat button.
There it goes. I found it. All right, so my first question for you guys is, what's the best way to survive a zombie apocalypse? A, run faster than your friends. B, hide in Costco. C, become friends with zombies. Or D, Google it and hope for the best. Wait, why am I see a lot of B's? Hide in Costco. Hey, I like the A. I actually would have chose A as well. You know
Mhm.
what they say. You just gotta be faster than the slowest person,
Well,
right?
you know,
That's cool. All right. So, civil engineering. What is a civil engineer? A civil engineer is actually someone who designs, builds, supervises, and maintains an infrastructure project like roads, bridges, buildings, airport, tunnels, and water system. I just took this definition out of Google. I think it's the best way to kind of describe it. And then, as we talk more, I'll give you guys a better explanation of like what I do as a civil engineer versus like because it does get a little bit more focused, but as I continue to read this. Their work blends technical knowledge, project management, and problem solving to ensure structures are safe, efficient, and sustainable. And I made sure to highlight problem solving because I think that's the main component of being, I would say any kind of engineering, but a lot in civil engineering, we do a lot of problem solving. And also I included a little bit of the salary here. The average salary you can see really depends on the market. It all depends on the market where you're located. If you're living in Chicago, if you're living in California, Minnesota, it can range. But I found some data online. The average salary is about 98,000 per year. Entry level is usually about 71. But with with more experience, and as you pass your certifications, and in civil engineering, there are two certifications that you need in order to become, you know, to really form into the field. And the first one is your FE, and that's actually something that you can. That's a certification that is recommended or recommended in all type of engineering, but it's mandatory in civil engineering because in our field you're dealing with people's lives, so they expect you to have that certification. But if you're doing mechanical engineering as well, it might be nice, but not recommended. Is what I've heard. Again, the first certification that you need to have in I'll just go ahead and say engineering is your FE, your fundamental of engineering license, and you usually get that. I mean, you can get it at any time, but it's recommended to get it just right after high college, and that's basically for I forget how long it is, but it encompasses all the things that you learn during school. So, but after a certain number of years of experience, there's a second exam, which is called the professional engineering exam. And that's a little bit more work related. It's a little bit more specific based on what you're actually doing. And all that allows you to, I guess, take advantage of a more higher salary positions. And this is why the experience salary is a little bit higher than the average. So in civil engineering, there are a lot of different types of civil engineering. This is something I like to share with people is that when you're in school, you're actually learning about all different types of engineering and eventually deciding which one you want to go into. So it's not just, I guess, well, I'm gonna say I'll just go ahead and talk about the list. You have structural engineering as one of the types of civil engineering. You have transportation engineering. So structural engineering, it deals with buildings, bridges, towers, just making sure that you have structural stability. That's for structures. There's a lot more math involved, a lot of math involved in structural engineering. You have transportation engineering, which is more roads related, highways. It's also bridges, rail systems, city streets, parking lots, drainage systems. I'm just kind of going and just thinking on top of my head some of the things that I've worked with because that's the type of engineering that I am. And then you have geotechnical engineering. They deal with more anything below ground, so soils, foundation, earthwork. Environmental engineering. They deal a lot with just water treatments, pollution control. You have water resources. They deal a lot with dams, canals, drainage. You have construction engineering. So it just kind of continues down. Um, I think the list goes on than what I'm sharing over here. But when you embark into civil engineering, just remember that there are more focused versions of civil engineering. Okay, so let's talk about my experience. Um, see, I my early engineering interest was was during high school, but I wouldn't say it was more engineering, but I remember taking my first physics class in during my senior year. And I've always liked math. I've always known that I enjoy math. Math came easy for me, and but I just didn't know what to do with math until I took my physics class, and I was just like, wow, here's some applications that I can use with math. I can combine with math. And these physics classes are more, how things works, how things work, the universe, um, even we've had like I'm sure you guys have done maybe in your I don't know if you guys have done like those engineering competitions, or if you guys have taken physics classes where you guys done the little experiments. But I remember we did the bridge construction experiment, and I was so excited. I went home and I put it all together and came to school that day, and I don't remember what place I got, but my bridge was very strong. And it was during that day that I realized that I just love putting things together, and I love calculating things. I love putting math into practice, and I just love I didn't know what it was. I didn't know exactly what it was, but I came to learn that what was happening, what I really enjoyed was a type of engineer. So physics was the catalyst or the conduit that got me to where I am today. But so I went to I after I graduated after I graduated college, I'm sorry, after I graduated high school. I attended Hamlin University. I'm from Minnesota, so Hamlin University is in St. Paul, Minnesota. And again, before I decided to go into engineering, I I I knew I loved physics in high school, so I wanted to continue that in college. So actually I studied physics and applied mathematics for a couple years. While I was doing that, I was also an athlete. I played football, and that was actually really hard to juggle. But I enjoyed physics. I enjoyed physics a lot. I enjoyed math. I managed my time wisely, and also during my education, I was a tutor, which I think really helped out to kind of like learn and take on a lot of the information while kind of helping others. Because I don't know if you guys ever been in that situation where you you understand information a little bit better when you explain to other people. So that was kind of like my cheat code back then to retain all the information is through teaching other people. And I just I just started building up on my physics, on my math, and it was really fun experience. After about 3 years at Hamlin University, I decided to transfer to the University of Minnesota, which is a bigger university in Minnesota, to pursue an engineering degree. So there was two options that I was thinking about. I was either curious about mechanical engineering or civil engineering. So it was kind of like a flip of the coin a little bit. And I ended up choosing civil engineering. And I loved it. I loved it. I never looked back. I don't know what my life would have been like if I did mechanical, but um, civil engineering has been one of my, I mean, it's my, I'm glad I made the decision that I did. So some of the courses that you would expect in in engineering, you have your pre-engineering courses, and this is like the same in all engineering. You have your pre-engineering courses, and then you actually have your engineering or civil engineering courses. And a lot of us pre-engineers all come together. So you have everybody, all engineers need to take physics, calculus, chemistry. You have your statics and your dynamics, and as well as other elective courses. So obviously not gonna list every class I've taken, but when we start freshman year, we're all together, all engineers, all different types of disciplines come together, and we're all taking physics, we're all taking calculus, and then eventually the classes size start to get smaller as people start deciding what they want to do. But afterwards, once you decide what you want to do, civil engineering, you have your more focused classes like soil mechanics, transportation, wastewater treatment, and all these again are very broad. You're kind of dabbing into all the different types of civil engineer disciplines. But eventually still trying to figure out exactly what type of engineering you want to do. So eventually your last year or so, year and a half, you've kind of already decided, I want to be a structural engineer, I want to be a transportation engineer, I want to be wastewater. So now you're taking what we call upper level classes where it's very, very focused. So you're taking more higher level transportation engineering, you're taking higher level steel, it's called steel and concrete. But one class that every senior level person takes is capstone. They call it differently in other universities, but what that means is it's a class where you only meet a couple times. I think it's once a week. I think it's once a week. I forget, but basically what it is it's kind of like an independent group. Like it's a group project. You have a group project where you're advised to go out there and meet with actual industry experts, and you you put together and trying to solve a real life problem. And at the end of the semester, you have to present your findings, and you're graded based on what you're able to solve, the difficulty, the team collaboration, and you do that twice, which is really fun. It's really fun and nerve-wracking because I think that was like my first time I ever had to give a whole presentation in front of like very smart people. It's kind of crazy because you're teaching professors about the things that they teach you. So it's like, wow, I hope they don't think I'm stupid. But um, but yeah, so that's called capstone. Again, there's other names in other universities, but I wanted to kind of show you guys a little photo of some of the problems that we had to solve during the university time. The Zen like so here to my just to the right there, bottom is don't don't ask me to solve this. It's been some time, but if that problem scares you, then you're definitely ready for a civil engineering or any type of engineering because I'm every engineer problem scare me. Okay, what's next? All right, so like I said, I am a transportation engineer and I mostly design and manage infrastructure roadway projects. And I work for a company called Infrastructure Engineering, and we're located in downtown Chicago is where our base is, but we have other companies in other states across the country. It's a fairly small company, so about 100 people, 100 plus people now. I think we're growing, but we're getting close to about 200, growing every year. But I kind of love that aspect of the smallness. My CEO is right across the room. I get to talk to him. I say hi to him all the time. VP, team leads. So that's I can't. I've never really worked for a really big company, but I've always enjoyed that small little community where you have really one-on-ones and really get to know your coworkers and anybody else who makes the big decisions um um in in the company. Hold on, guys. I'm trying to pull up my slide again. Okay. So, what does a typical work week look like for me? So I would say one thing I love about my company is I know it's not the same everywhere, but ever since COVID happened, a lot of us have gone remote. I'm sure maybe you've heard that a lot with a lot of the engineers that has come, especially like the computer science folks. A lot of them tend to work remote, but that was a big change for us in the civil engineering world, where a lot of us started going remote because they didn't really know if it was possible, but it's kind of like COVID forced us to kind of learn something new, and we realized quickly that this is manageable and we can still get the same amount of productivity work done while working remote. So I have a more hybrid work schedule. I go to the office once a week, or once or twice a week, but we as a team have decided that on Wednesday is a day that we all have to go in the office together. And collaborate. And there's a lot of benefit definitely to be in the office, but I do like the flexibility of being able to, as you can see in the photo to the right there, wake up at 7:59 and just, you know, hop on my desk at 8:01. I'm working. And I love that. I can't imagine kind of going back to more of an office 100% space. But we have because it is hybrid, we require a little bit more meetings, lower conversations with people. So on every Monday we come in, I wake up in the morning and log in and we have a team meeting. And we usually kind of talk about what we're working on, how our weekends was and have and answer any questions that anybody has any regarding the project that they're working on, and see if we can all kind of collaborate and help each other out. I have a more independent work style, self-managed. I kind of wrote that in there because something that you guys are gonna something that you guys are gonna try to figure out, like what kind of work style you guys enjoy, and whether it's you like whether it's like micromanage or more self-managed. That's something that I chose because I know how to I've managed projects for a long time. I know how to prioritize. I know how to manage my own time. I know deadlines. I know how to reach out to people. So I like to be able to manage my own time rather than someone's coming in here every single day and asking me, "Hey, do this, do that." We need to get this project done by the end of the day. A lot of my projects tend to last more than a week, more than a week. So just imagine I come to you and I say, "Hey, I need you to finish this homework and I need you to turn it in 2 weeks." But that's it. Just check in with me on Friday. Check in with me on Friday and let me know how it's going. Let me know if you have any questions. And that's as much directions I give you, and it's up to you to really to take it as far as you can. It is definitely recommended if you are working in that style of environment to be self-motivated and always try to do your very best, because the client is going to see your work, so you can't be slacking. Otherwise, that independence kind of gets taken away from you, which you don't want that to happen. So the type of softwares I use are MicroStation. I'll talk a little bit about MicroStation a little bit later. Excel, I use Excel a lot. Bluebeam is a PDF looking like tool where we can edit edit our PDFs live. It's interesting. So we use that to mark our plan sets, add comments, answer comments, all the different things from whoever is reviewing our plan sets. Um, if you guys are confused with what I mean by like anything, I don't know, maybe you can go ahead and ask me at any point. Please ask any questions. Ask your questions. And again, like I said, small team environment is kind of like my typical work life, I guess, balance or dynamic. All right, let's see what we got. All right, next question. So now we're gonna go ahead and put our engineer caps on. It gets a little harder. All right, you are okay. So you are an engineer, transportation, tasked with improving safety near a school. What's the most effective solution? All right, A, add more streetlights. B, widen the road. C, install speed bumps and crosswalks. D, build a parking lot nearby. What we seeing here? Okay. You guys are smart. You guys are very smart. I thought maybe, you may have to, wait, let me see. No, I think C is the best answer. Build a parking lot nearby. No, it's not gonna help. I mean, you could add more street lights to kind of slow down the road a little bit but I think C is probably the best answer. Install speed bumps and crosswalks. Good job, guys. You guys are ready to do my job. Okay. How we doing with time?
So in like 6 minutes, because I remade the Zoom link for my account, we don't have like the subscription. I'm gonna need like in 5 minutes everyone to like leave and then rejoin because like there's a 40-minute timer that I have.
Mm,
Yeah.
But
okay.
If
we have like
if you're done with the presentation or almost done, maybe
oh
we can start doing the Q&A session or like after.
yeah, that
Oh,
would also be
oh,
great.
oh, I wasn't done. I had a full hour. You guys
Oh,
gave me an
okay, okay,
hour.
Oh,
good.
no problem, no problem.
But I mean, I can just tell me how much time do I have? So
After
I
everyone
can
rejoins, you have like 10, 15 minutes. Yeah.
wait, this is a 15-minute presentation?
No, this is an hour long presentation.
Oh, okay. 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 All right. So I'll just continue. I'll be quick, but um so I wanted to kind of show you guys some interesting project that I've worked on. And this is a cover sheet for it's for an alley reconstruction project. And instead of just kind of going over the project on the PowerPoint, I wanted to just kind of show you guys what it looks like as I kind of design it. Can you guys still see my screen?
Yeah.
Okay, so this is a quick Google Maps image of the alley. The alley, this is Chicago, map of Chicago. And we just kind of zoom in to our street or my corridor that I'm currently working on. And this is just we call this a H-shape alley, but our the scope is complete reconstruction. So we're gonna remove all the concrete and put new pavement in. We're gonna update. We're gonna upgrade the alley aprons. Is what we call alley aprons. Maybe you guys call it. I don't know what you call it. Just it's an entrance to the alley. But our scope also includes sidewalk the sidewalk improvements. And what we have to do is we need to determine if they're compliant. Compliant means if people it's not too steep. It's not too steep for just an average person walking, but also another term is ADA compliant, and that's more related to anybody in a wheelchair, anybody who needs a little bit more assistance, and it has to be compliant for that as well. The sidewalk and drainage, you probably won't see that, but see on this image. But we have these are called manholes. These are called manholes. There are also other types called catch basin. The difference between a manhole and a catch basin is a manhole is just meant to to hold the water on. So there's a big pipe underneath, and I'll show you kind of like a profile view of it later. But the manhole is meant to hold the water. A catch basin is meant to take in the water. So the lids are usually, if it's a closed lid, which is what you're seeing in this Google image, this is more of a manhole. If it's an open lid, which means you can look and see underneath inside, that's a catch basin. So water is kind of flow drain into that. So the alley is long. Alley's long. We have our garages. We have our entrances, people's private entrances here. We have light poles. We have what I call light poles. We have just all the different things that we need to consider. And another thing that we need to consider while we're designing is every time you see a garage, you need to make sure that you redesign the garages as well. Just the entrance, just the entrance area to make sure that the water is not flowing towards the garage. So there's a lot of math, a lot of iteration that you have to consider while you're designing a whole entire alley. And what we use to design, and we'll look at this. What we use to design is microstation, and I kind of mentioned that earlier, but this is the tool called microstation. And if you guys remember what the alley looked like, and I said it's an H-shaped alley, but in our design, this is what it looks like. And just quickly, these are the design. This is how we go through and plan out the alley aprons. All these boxes are the squares that you saw, in the Google Maps for the the ramps, and all of them need to be compliant. You can't see on this image, but there are slopes that we have to consider, that we have to show. So there's a minimum amount that, or there's a minimum maximum, but we have to maintain, oh, maximum. We have to maintain a maximum of 1.5% crossing and all the way through. And all these different um, aspect of the apron has have different standards, and I'm definitely not gonna go through all that with you guys. It'll take forever. But in this project, we're gonna be adding, we call these pavers. We call this pavers. Maybe you guys can kind of imagine that if you ever see an alley with low bricks in the middle, brick pavers in the middle. That's what those are. We're adding pavers. Um, and it just kind of goes in. You see dimensions everywhere. That there's all the dimensions of the garages, and these points right here are the elevations. The elevations. So the ones that are with the bracket on it are the existing elevation, and the ones without are the proposed elevations. So uh, we have to make sure, like I mentioned earlier, that that water is flowing away from the garage. So the proposed elevation has to be less than the existing elevation. You can see here 6.72, the existing 732. So we know water is flowing in that direction towards the middle. And we'll go to a different viewpoint. And this is more like now we kind of cut the road towards the center. So this is only one part of the alley. This is the top H1, the H, and this is what you're seeing underneath the ground. This is what I was telling you about. Actually going to be installing a catch basin. There's an existing manhole, or we're going to install a catch basin because, as you can see, that what the profile. Am I confusing anybody? I'm speaking really fast.
No, you're good. I was just
No,
gonna
you're
say,
fine.
sorry to cut you off, but I was gonna end the meeting and then have everyone rejoin because the meeting ends in like 30 seconds.
Okay. All right,
Yeah,
let's go ahead and do that.
All
sorry.
right.